Hi folks, welcome back to Math with Captain Rod. Making this video here to provide a couple examples of applying right angle trigonometry to solve problems. So we're going to look at a couple of examples here. We'll start with example 1 here. We've got a triangle, a right triangle, meaning that that's a 90-degree angle. We've got a 60-degree angle here, side of 10 on the base here. And we're going to go ahead and try to find all the other properties of this triangle. We're going to try to find this side, and this angle. So the first thing you do is you typically label your unknowns here. So here we have an unknown angle. I'll go ahead and label it theta maybe. You can label that angle any way you want. Here's an unknown side here. So let's see, I'm going to call that side y. And again, you can call this anything you want. Here's another unknown side. I'm going to go ahead and call that side r. All right, let's get going on it. So the first thing we're going to do, let's take a look at this. So here's a 60-degree angle. Here's an unknown y, and this side y is opposite the 60, and 10 is a known side. Now the 10 is adjacent to the 60, so if you think about SOHCAHTOA, let's see here, I don't use that very often. Tangent is opposite over adjacent, so I look over here, we have 60, here's the side opposite, here's the adjacent, so I'm going to go ahead and use the tangent function on this. The tangent of 60 degrees would then equal y over 10. To solve for y, you just multiply both sides by 10, so y should equal 10 times the tangent of 60 degrees, and I've already went ahead and calculated a value here, whoops, although I can't read my own writing, so I'm going to double check this. Okay, 17.3 approximately, good enough. All right, next, so this is now a known value. Oh, let's see. Let's go after r now. Now, r is the hypotenuse here, and we know the side adjacent. So let's go ahead and use the cosine function. The cosine of 60 degrees is the side adjacent, divided by the hypotenuse, in this case is r. So now we want to solve this for r. First step would be multiplying both sides by r. And over here they're going to cancel. Next step would be divide by cosine 60. So if we do that, we're going to have r equals 10 over the cosine of 60 degrees. And that will come out to be 20. All right, so this side we know now is 20 units. Now, we also could have used the sine function. The sine of 60 would be 17.3 over r. That would have worked just fine as well. To get theta, well, in Euclidean geometry, the three angles shown have to add up to 180 degrees. This one's 90, and that means these two angles have to add to 90. So if I actually wrote an equation for that, 60 plus theta is equal to 90 degrees. Solving that for theta, we get theta equals 30 degrees. So this triangle now is completely solved. We know everything about it. Let's go over here and take a look at example 2. All right, so in example 2, we've got a triangle with a couple of unknown sides here, a side that's length 5 and a side of length 12, a 90-degree angle. So let's start labeling unknowns here. Let's see, why don't we call this one theta and this one alpha. You can call these anything you want. It's very common in trigonometry. Trigonometric types of problems use Greek letters for the angles. Let's go ahead and call this side y. All right, so let's go after theta here. We'll start with this. Notice that we know the side opposite theta and we know the hypotenuse. So if we want theta, a good place to start would be the sine function. So I'm going to go ahead and write out that the sine of the angle theta is equal to opposite over hypotenuse. That would be 5/12. Now, I have other videos about this, about the arcsine or cosine arctangent functions. I'll just say this, right? This equation is solved by taking the inverse sine of both sides. If I actually wrote it all out, the inverse sine of sine theta equals the inverse sine of 5/12. Now, when you apply the inverse sine function, you're going to get an angle between minus 90 and plus 90. in triangle problems like this, these angles are always positive, so you're going to get an angle between 0 and 90. So what we're going to have is theta equals the inverse sine of 5/12. You just type that in exactly the way you see it, and I get 24.6 degrees out of that. All right, so that's now a known value. All right, next, the sum of these two has to equal 90, so alpha plus theta, 24.6, is equal to 90 degrees. You can solve that for alpha just by subtraction. Looks like I got 65.4 degrees. So that's now a known side. Now, once these sides are known, to go after y here, we can use either angle, and we can use any trig function we want. It really should work out. Well, I guess I shouldn't say any. If we use alpha, we either need to use the tangent function or the sine function. And if we use theta, we would use either the cosine function or the tangent function. I'm going to go ahead and say this. The cosine of 60 degrees, right? So that's the cosine of the, oops, I'm sorry, not 60. I meant theta. The cosine of the angle theta would equal the side adjacent divided by the hypotenuse. So y is going to equal 12 times the cosine of theta. Now we found theta to be 24.6 degrees. Then you just type this in just the way you see it, making sure you're in degree mode, by the way. All these examples have been in degrees. And I get 10.9 out of that. Now, as far as checking your work here, I've used sines and cosines to find these sides. Here's how you can check your work by applying Pythagorean theorem. In this example, 5 squared plus y, which we found to be 10.9 squared, should be equal to the hypotenuse squared. I'm going to leave this to an exercise to the reader here to decide whether or not these are equal. Now, we rounded, so what will probably happen, this right-hand side is 144 exactly. But these are, rounded values, or at least this one is. So you'll probably get something like 143.8 or something, or maybe 144.2 or something. But you'll get something probably very close to 144. Over here to check our work, we want to be sure that 10 squared plus 17.3 squared is equal to 20 squared. And again, I'll just put a question mark there. And again, I'm just using Pythagorean theorem to check our work. I'm going to leave this as an exercise to the reader. Check the sum of these two things and make sure it's approximately equal to 400, and that would verify that these results are good. So the point of the video was to provide examples to help you understand how to use the right angle trig stuff. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. See, I mentioned earlier in the video I don't use this stuff very much, but applying right angle trig to solve problems to find the various legs. I hope that this video helps you understand that. Have a great day.